capacitor combinations, and we're going to start by learning how to work out the total capacitance. We've got a couple of different capacitors hooked together in parallel, and more importantly, we're going to learn why as well. So if we think about our capacitors, each capacitor holds a charge Q at a voltage V, and it's got a capacitance C. So Q1 is C1 times V1, and Q2 is C2 times V2. And there's an obvious simplification we can make to start with here, which is that because these two capacitors are in parallel with each other, what do we know must be the same on both of them? Voltage. And so we don't need to have a V1 or a V2. We've just got a V. And what we're interested in is the total capacitance of this combination. And what we know is that the total capacitance is equal to the total charge over the total voltage. And the total charge, we've got Q1 on the first capacitor and Q2 on the second capacitor. So C total, we can rewrite that as Q1 plus Q2 over V. And it actually doesn't matter, both the capacitors have the same voltage, so V1 is V2. And so we can rewrite that as C total is equal to Q1 over V1 plus Q2 over V2. Hang on, if we think back to over here, C1 is Q1 over V1 and C2 is Q2 over V2. And so really all we've written here is that C total is just C1 plus C2. The way we've got to that equation is just by knowing that both capacitors must have the same voltage on them because they're in parallel, and the total charge stored in any combination of capacitors in parallel has to be the charge on the first one plus the charge on the second one. So that equation there is only a formula